Today we're going to start talking about identities, and we're going to start with triangle problems. So, first, what is an identity? If we know that sine of 20 degrees is 0.34, is there a quick way for us to figure out what sine of 40 degrees is? If I double 20 to get 40, is it going to be just 0.68? Can I double it that way? That's not exactly how it works. It's not that easy. Just think unit circle values. Sine of 30 is 1/2. Okay, well if I double 30, does that mean I double 1/2? No. Instead, we have to use identities. So these are your double angle identities. If you want to double the angle, then you take 2 times the sine fraction for the original angle times the cosine fraction of the original angle. And then also we can figure out the cosine fraction of that double angle. It's cosine squared of our original angle minus sine squared of our original angle. 2 other ways to rewrite the cosine 2 theta identity is down here. I usually just use the first one. You only have to have the first one memorized, but know that these are also options. And I forgot to mention, remember tangent is sine over cosine, so tan 2 theta is sine 2 theta over cosine 2 theta. We'll get to these identities later. Okay, so what we're going to do today is I'm going to give you problems like this. I'll give you a cosine fraction and then ask you to find the cosine fraction if I double the angle, or the sine fraction if I double the angle. We're going to follow the same steps we did before when I gave you a cosine fraction and said find the sine fraction, find the tangent fraction, so on and so forth. So we're going to draw a triangle, label our sides. You may need to create a fraction by writing your original number over 1 to label your sides. We're going to find the third side with the Pythagorean theorem, and then if you're on the units, or if you're on the coordinate plane, you need to pay attention to what the sign is, plus or minus. Otherwise, you can skip this step. And on your second test, the last step was set up your SOHCAHTOA fractions. This time, our last step is going to be write out identities. And replace with SOHCAHTOA fractions. Okay, let's do an example so all that makes sense. Let's do the example I just showed you. Given cosine theta equals 3/5, determine the exact value of sine 2 theta and cosine 2 theta. So if we double this angle, how does that change my cosine fraction and how does that change my sine fraction? All right, we're going to start with triangles. Draw a triangle. You can orient it however you want to because this doesn't give us a specific quadrant. I like to put theta in the bottom corner, but you can put it wherever you want to. And so if theta is in the bottom, that means across from theta, this vertical side is my opposite. Beside theta, this bottom side is my adjacent. And across from my 90-degree corner is the hypotenuse. Cosine, the ca fraction, is given to us. So my adjacent side is 3 and my hypotenuse is 5. We just did the first 2 steps. We drew a triangle and we labeled our sides using words and numbers. Now we need to find the third side with the Pythagorean theorem and then write out our identities. So third side with the Pythagorean theorem, I don't think I need to actually do this with you. You should end up getting that b equals 4. All right, last step. Now I'm finally ready to find sine 2 theta and cosine 2 theta. Sine 2 theta is the identity or the formula 2 times sine theta times cosine theta. So that's 2. I can replace sine theta with the SO fraction, and I can replace cosine theta with the ca fraction. What does that mean specifically for this problem? The SO fraction is 4/5, and the cosine fraction is 3/5. If you need to write 2 over 1, so that way you have 3 fractions here and you don't get confused. But now that I have all these 3 fractions here, I'm multiplying. These are multiplying. So multiply all of that together. 2 times 4 is 8. 8 times 3 is 24. And on the bottom, 1 times 5 is 5. 5 times 5 is 25. So the sine fraction, if I double the angle, is 24 over 25. Yay. All right, I can do the same thing for my cosine 2 theta fraction. You can use any of these 3 identities that I've given you. I usually just use the first one, but any of these 3 are good. So let's write out cosine squared theta minus sine squared theta. Replace cosine with the ca fraction. Cosine was squared, so I need to square my ca fraction. Replace sine theta with the so fraction. Sine theta was squared, so I need to square the so fraction. You don't have to write this step. I'm just trying to be clear for your notes. All right, now I'm going to actually fill in my numbers. So the ca fraction is 3/5 all squared. The so fraction is 4/5 all squared. So that is 9/25 minus 16/25 for a total of -7/20.